If you can't retrieve data fast, you can't make queries fast, period. Today, we are breaking down 3 basic paths an index takes to return your data. Hi, I am Jakub from DB Booster Academy. In this episode, we will break down index range scan, also known as an index seek, index full scan, also known as an index scan, and index skip scan. By the end, you will know what each one does. Let me introduce my sample table. It contains movies. The columns are ID for primary key, movie name, country of origin, score from 0 for the worst movie to 100 for the best one, language, status, which means banned or released, and a few others. Let's start with an index range scan. In SQL Server terms, and an index seek. I am using an index on language and score. I am searching for rows where language is Chinese and the score is 4. First, I need to traverse the tree. The database follows pointers, root, internal nodes down to the first leaf page that could contain our value. The next step is to find the first match in that page. And finally, read forward while it still matches, and stop when entries no longer satisfy the filter. You can think of it as 2 steps. Step 1, find the first matching row, go down, and step 2, scan the matching rows forward. Each matching row may require a table lookup via the row pointer. Every lookup adds extra I/O, making the index range scan more expensive. The efficiency of an index range scan depends on your data. In my case, there are only 4 movies in Arabic, but more than 70% are in English. These 2 cases behave very differently. Searching for 4 movies is cheap, even with lookups. By contrast, reading roughly 70% of the index with lookups is much more expensive. However, cost isn't driven by selectivity alone. It also depends on the shape of the query. Take order by. A range scan isn't only for searching. When the order by matches the index order, the engine can stream rows already sorted, so no extra sort step is needed. Let's say I want all movies in Arabic ordered by score. First, I descend the tree and find the first matching row. Then I scan forward through the rest of the Arabic rows. Those rows are already ordered by score, because score is the second column of the index. By the way, I'll cover condition types, equality, non-equality, and sorting in the next episode. This is a quick overview of where a range scan can help. Now let's touch group by and aggregates like min and max. If I need the minimum score for Arabic movies, I only need the first entry in the range. If I need the maximum score, I want the last entry in that range. That's where a reverse range scan comes in. Databases can traverse a B tree in both directions, forward or backward. In backward range scan, the engine descends to the highest matching value and, if needed, scan backwards. However, for max, the first row it encounters in that backward range scan is already the answer. The index range scan is the basic index access path and the one you will use most during performance tuning. It can help with filtering, sorting, aggregation, and joins. Important point: to use a range scan, your filter must use the leading columns of the index. We call this the index prefix. With an index on language and score, I can seek when I filter by language and score together, or by language only. But I cannot do a range scan with a filter only on score. The engine has no place to dive into the index. It cannot do the first phase, the go down, because the value which it should dive into is unknown. To solve this issue with the leading columns, there is an optimization called index skip scan. Let's assume that having index for language and score, I want to do the search for score equals 4. Skip scan simulates the missing prefix and still does the search. The idea is simple. Since there is no predicate on leading column, in my case language, the database runs multiple small range scans, one for each language value. I have 54 distinct languages. Doing 54 range scans is probably slow. Now imagine a different index: status, language, and score. The query filters language and score, but not status. However, status has only 2 values: release and banned. Here skip scan is cheap. The engine does 2 range scans. First, a range scan for status equal banned and language equal Chinese and score equals 4. And second, a range scan for status equals released, language equals Chinese, and score equals 4. I have 2 rows for movies in Chinese with the score 4, so these 2 range scans are cheap. As you can see, the order of columns in your indexes matters. Note: index skip scan isn't supported in Microsoft SQL Server. Let's take a look on index full scan. In Microsoft SQL Server, this is simply called an index scan. You can think of it as a special case of range scan, where the starting point is the very first value in the leftmost leaf of the index, the lowest key in the index. The scan phase follows reading all needed rows. There is also a reverse version that starts at the highest value, the last entry in the rightmost leaf, and reads backwards. Index full scan can be useful when the index is covering and there is no filter. Imagine a table with a few hundred columns, but your query needs only, let's say, 10 of these. The index is much smaller, so a full index scan can outperform reading the huge table. Another benefit: rows read by a full index scan are already ordered, so some order by clauses can be satisfied without a separate cost for sorting. These are the 3 main index access paths: range scan, skip scan, and full scan. Different databases refer to them by different names, but they operate on the same principles. Next time, we'll dive deeper into how indexes handle filtering and sorting, from single column equality filters to ranges, and when indexes help avoid sort operations, and much more. Thank you for watching. If you found this useful, give it a like and subscribe for more. And take care.